Hello and welcome to today's panel discussion on AOI and X-ray inspection in the semiconductor world. So AOI and X-ray technologies are continuing to evolve essentially for the SMT industry. But how do they fit into the more demanding semiconductor business? Hopefully my panelists today will be able to help me answer some of these questions. I'm joined by Rui Guisero from the Mertec sales partner GPS, and of course Carsten Saluski from Viscom. Nice to see you.
Thank you, Trevor.
Okay, great. So let's get started with the first question, and maybe we could talk about how do these technologies help to improve semiconductor or component yields today and going forward. Who wants to take that first? Yeah.
So maybe I can start just saying from the AOI business mainly, as as Mirtec focuses on this part. So I think the most important thing for any kind of development is having enough data to see the errors you're manufacturing, to make the right decisions, to counteract them in your area. So having the different technologies like Moiré projection, laser scanning, and so on, to have a different access to the different surfaces and the different steps in the semiconductor manufacturing, I think improved the manufacturing itself a lot and helped analyze what the initial problems were and helps better the yields over time for the different manufacturing steps, as we see when new nanometer production comes into place. At the beginning, very bad yield, so the initial production is not as we would like it to be. Then they approach us to see, hey, what are we doing wrong? We help to analyze the whole stuff via different methods from X-ray to AOI, and then they get enough feedback and enough data to see, okay, what do I have to improve in my production side?
Right, right. Well, I mean, you know, there's certainly a lot of technologies we can take forward into semiconductor from the SMT business, but I mean, we're working at much tighter tolerances, are going down to micron accuracy. What's your take on it?
Yeah, no, exactly. Where to start? So I think in general we see that different from maybe 10 years back that we have more overlap between the semiconductor backend and the SMT assembly line, especially in the packaging process. So we can apply technologies that are used for standard PCB inspection with a little bit higher resolution, but the same technologies on an inspection task at the back end of semiconductor. And I mean, semiconductor is a wide field, so wafer inspection, we did that at one point, but currently that's not our focus on the wafer level nanometer structures. We are not really
more back end packaging.
Yeah, and I think there are very advanced players on the wafer level, but when they get to the macro stuff, to go. So they don't have the tools that we apply for many years in the SMT assembly line. So with our AOI and AXI solutions, we have many applications now that are before the assembly line, like solder bump inspection, everything that is with a die, and micro cracks is something that we're really looking at. And here it becomes interesting how to do that, because cracks are not really what we're looking at in the SMT process, but that's where we can advance, right?
Right. Okay. So that can you sort of more or less come into my second question, which was going to be which parts of the chip fab process can AOI and X-ray inspect. So you mentioned micro bumps and cracks and that sort of thing. What about on the X-ray side? What can you really go down to there?
Most of the applications that we have in the semiconductor world are X-ray related. So we can do 3D analysis, for example, a solder joint below the die, where we do some morphology of solder joints to understand if there's a good one, a crack, or something like that. But another field, which is also semiconductors, power electronics, where you have a lot of area soldering, DCBs, so direct copper bond or direct bonded copper, both ways, where we see applications that are mainly X-ray to find voids in heat sinks, in connections to heat sinks. And for example, IGBT inspection is something where we see a lot of applications right now with X-ray.
Right, right, okay. And really, do you know from the AOI side, what sort of size of features you can go down to for inspection on the semi back-end packages?
Yeah, so that was a very good point. So the transition from the wafer to the actual finished product is where most of the X-ray and AY steps will come in, since the original product is extremely shiny. So visual inspection is very challenging, and the moment you want to start packing it, bonding it, then is when you have different surface levels. So you will need different technology. So there are some things can only be done via X-ray, but it's mostly not enough for the customer. So there are still steps in visual inspection that they demand being done visually. And these, to be honest, are one of the most challenging parts we have for the visual inspection, because a lot of the times you are working with different surfaces with very tiny issues that you have to find, very tiny faults, and this is what makes it actually pretty fun, because you have to come up with new technologies to solve that issue. You can't just reuse what you do in the SMT show, so you have to improve on that and do on top. But yeah, this is where we come in when you start packaging, when you have very tight packed situation, when the first die comes in, and then you have a lot of tight packed surfaces, and the high combination of very shiny surfaces and very dim or light absorbing surfaces. And this is when we have to try to find which kind of technology or which combination of technology can be the actual solution.
Right.
Is it Moray? Is it laser? Is it X-ray?
Yeah, I mean, definitely shiny surfaces have definitely become an issue in the semiconductor field, but even in the soldering field, you get shiny joints, and you get on the SMT side, it's quite an issue. What about the smallest features that you can inspect down to at the semiconductor level? What are we looking at?
Yeah, from the SMT. Maybe we take this one. So on the SMT side, we usually it starts somewhere in the 4-micron resolution, but especially for semiconductor applications, we have an 7059 system now with 1-micron resolution in a prototype version, and we see a lot of applications for that. Where you find smaller voids in connections, and especially in the DCB inspection area, there are a lot of small defects that you can find with those.
Right. Okay. We're gonna have to share a microphone, I'm afraid. So, Rui, going back to you just for a minute. I mean, what about keeping up with line speed with some of these inspection technologies? Because do you have to slow the inspection down to be able to get to some of these resolutions?
Well, in the visual inspection area, you have what's called the field of view. So you actually you cannot see the whole object most of the times at once. So the finer your resolution will be, so getting down to 1 or 2 microns, the smaller the actual size of the field of view will be. So instead of having like 5, 6, 7 centimeters field of view, you suddenly only have 1 or 2. So that means that you will have a slower process. So of course, how do you solve this? Do you solve this just by putting like 4 AOIs in a row, and this is how you're going to do it? Do you do multiple lines? Do you have multiple cameras doing it? Or will you try to combine, as we talked before, certain applications to lift that problem issue with the tech time and go like, okay, I can solve this error with this kind of technology, and I will solve this, and then through the combination to keep up with the production speed, because it's always a race.
Would you agree with that? That's okay. Would you agree with that, Carsten?
Yes, in general, yes. But I think there's a lot of differences between the assembly line and the semiconductor environment, where we work more with recipes, and there's also a way to go from we call that a lab to fab approach, where we have an offline, failure analysis system that an offline. Online, yes. Okay, so lab to fab means we have offline X-ray equipment that can already do sampling and so on, maybe at line inspection, and then we can go like for 100% ramp up also into an automatic 100% inspection mode with a different system. But we use the same tube and detector arrays to do that. We do that in many other fields as well. So yes, I generally agree. Do you also do wire bond inspection on the semiconductor side?
So I leave the wire bonding inspection to you guys. So we can do it,
Yeah.
but it's very challenging. I always tell the customers it's nothing worse than having to look visually at something that has the same color as its background, and then you're coming with oxidation and other stuffs that we have to take in account. So for the human eye, for your brain, this is a different situation. You look at it, you can see it, but the challenge itself is twofold. First of all, you have to have visual optics that make it possible to see it. And second one, how do I... Okay. Seems like I'm sharing trade secrets. I should not. My boss is cutting me off. I'm very sorry. So, and the second one is how do you translate what the user sees and what he realizes into an actual machine configuration? So it is a challenging application. We try to come up with new solutions. It comes. We presenting one of the possible paths to that. So how do you add more 3D information? Because as someone who uses the stripe projection moire, a shiny surface, and that is what wire bonding is very challenging. So by adding additional 3D data that is available for the user, we can make it more approachable to go there. But I absolutely agree, wire bonding is something that is very challenging.
It's a different technology, really, isn't it? Because, I mean, what you've got to measure is not just the look at the joints, the bonding that are bonded, the gold bonded joints. You've also got to measure the height of the loop for the bond. Yeah. That's equally important.
No, it's definitely more a niche technology at that point, and I didn't mean we have a lot of it in box builds. So we have a ceramic substrate and some dies on the substrate, but also the connection between the substrate and the box or the housing. But in packaging, it is it's not done as much as I expected. That I was curious about it.
Yeah, but actually, I totally agree. But for a funny reason, it seems like everybody's coming up now with the bonding stuff. So I've been only 11 years to the SMT industry, and I've heard the word bonding in the last 3 months more often than I heard it 10 years before. Right. So there are certain technologies that seem to be more needed now, maybe due to high voltage applications, maybe due to the EV market changing situation. So certain products that start to emerge. So the DCB, the double copper bonded stuff, and the wire bonding also comes to us, which is a very good opportunity because now we are reaching, even with established solutions, customers are looking like, okay, it was great until now. Now we need more. Now you guys have to do something again. So maybe this is why we are getting this request more and more now. So
okay.
looking very forward.
Yeah. So Carsten, I mean, how do you handle trays and let me see. Yeah, how do you handle wafers and trays safely?
Okay, wafer handling is a different topic. I mean, you have a lot of handling systems that just do the magazine in out and things like that. But we're not really very active in that field. On different trays, we know that from many applications. And I'm not the expert in the tray type, but it's a JDEC or something that we have probably more different conveyor solutions than we have machines, and we have a lot of machines. So there's always a little like a project-specific configuration of the handling part of it, but that's all mechanics, and mechanics, I think everybody can handle that.
I see most of the time is people using FOUPs to transport wafers into and out of inspection machines.
Yeah. Well, I totally agree. I had to laugh a little bit about we have more different type of transport and conveyors than we have actual machines. So yeah, that sums it up very good.
Yeah.
So you have to adapt to the environment. It highly depends if it's a closed loop production solution or if it's an off solution where you have to go between stages. So robotics comes in, certain transport systems. Of course, especially with waivers, you have to be very careful because you're on one side you should expect it, on the other side you're grabbing it with an extremely shiny surface, and then comes the next step
And
where
they're getting
you
thinner and thinner all the time, so they're getting more
yeah.
fragile. You know?
So it's a very challenging situation. So I totally agree. I'd rather stick to the packaging stuff. So
Yeah.
when we reach this level, it becomes a little bit easier. So high respect to those guys having to handle it beforehand.
All right, final question.
Okay.
How does AI play a role in analyzing the results of the inspection?
A lot. I mean, it's developing so fast. We started a few years ago, and we had the first applications maybe for 2 years in the field now. But customer demand is rising, and especially on the semiconductor field, you have a lot of segmentation, image processing, AI models that help you a lot with just identifying voids, finding wire bond, even crossed wire bond connections. So we use AI mainly as as a programming tool, but then also as an image processing, segmenting, object detection part of it, even image enhancing. So if you have some background noise or some background structures that you don't like, AI can help a lot, because it's like the human eye. Even in a complex image, you can easily identify certain areas that belong together.
Right.
And if you do that in deterministic programming with binarization and different levels, it's a lot of work. And our engineers like the AI tools a lot to do easier programming on the segmentation part.
Right. Yeah, and I've heard of it being used certainly in the programming side to make it a lot easier. But I've also been hearing about some companies looking at sort of monitoring operators as they're doing inspection over maybe a 3-month period, and then locking that into an AI system to do it automatically in the future, while the operator can look at more interesting or more difficult areas of inspection in other parts of the board.
Yeah. Maybe just to add to that. So let's say in a standard assembly line, the verification station where an operator can confirm a defect or reject a defect and allow it. That's something where we started with AI and just gave an AI assist function.
Yeah.
If the AI has another confidence in this is a real defect or not, and the operator makes a different decision, we said, okay, he gets a friendly reminder, look at it again. This was only a short time. After that, it's like AI is so much more accurate that 80% of whatever an AOI system or an AXI system presents can be just done by AI. So that reduces operator workload, but also has a high confidence in the decision making.
It improves quality. Yeah. Are you familiar with any use of AI?
Yes, I fear we are all working on the same stuff. So for us, it's a competition. For the customer, it's a win-win situation. No matter who comes out first, they have a better solution. So I couldn't describe it better. So it's the exact same process. So the first thing is, how do I make it easier to make the program? How do I make it more secure? How do I take away human error? By giving better tools. So what we used to do with the machine standardization and giving better mechanical and optical tools to do that, now we are improving on the software side. So AI, deep learning stuff that will make it less important if you're doing the first shift or the third shift of the day. The quality stays the same and the results stay the same. And then, of course, the customers want from us solutions how to counteract the demographic change. So they have less people. People are going to retire. Now, things you used to do with 5 people, you now have to do with 1 guy or 1 girl. So how do we solve that? So AI will become inevitable for most applications, even outside of AOI, because you need the assistance of the machine to make your life easier, to be able to take care of the other things that have to be done. because you simply don't have the manpower, while having the benefit to having a more secure process and making sure that you and your customers have the product they desire with the quality they desire.
Very well put. There you go. So, well, gentlemen, I think we've had a good debate today, and I want to thank you both for coming in. It's been an incredibly busy show here this week, so I'm sure we're all tired. So it's coming to the end. So I want to thank you, Rui Guerrero from the Mertec sales partner at GPS, and of course my old friend Carsten Saluski from Viscom.
Thank you, Trevor.
Yep.
Thank you very much.
And thank you to our audience for watching today.